In our last video, we talked about competing definitions of free will. Once you've decided what you think is the correct definition, you can then start asking whether or not any of our choices ever really do have free will or not. In this video, we're going to look at a neuroscience experiment from Benjamin Libet that many people have thought could help us try to answer this question. So in this video, we're going to talk a little bit about the relationship between neuroscience, brains, and decisions, and how that might help us study free will. We're going to talk about some of the precursors to Libet, EEG machines, and the discovery of the readiness potential. Then we're going to talk about Libet's own experiment. We'll introduce the Libet clock and the sort of purpose it played in his experiment. And we'll talk about the three things that Libet tried to measure in his experiment. And then we'll introduce what results he found when he actually ran the experiment. So why would it be important to try to study what's going on in the brain in order to decide whether we have free will or don't? Well, Mealy gives the idea on page 3 as follows. He says, almost everyone who believes in free will, no matter whether they go for premium, mid-grade, or regular grade free will, so no matter which definition they give, they believe that the brain plays an indispensable role in generating decisions. If a soul is involved, it works through the brain somehow. So the reason it might be important to study brains when investigating free will is that as science has progressed, we're getting more and more evidence that our beliefs, thoughts, desires, and consciousness itself is at least closely associated with activity that happens in our brain. So your conscious experiences are correlated with specific activity in your brain. When you feel pain or you see a computer in front of you, there's certain areas of your brain where there is more sort of electrical activity going on that we can actually sort of measure. And now similarly, when there are changes in what's going on in your brain, we also see changes in your mind, in your thoughts or experiences. This is the reason you take Tylenol. In your conscious mind, you might feel a headache, and then you take this physical pill, the Tylenol, that creates changes in the chemical makeup of your brain, such that hopefully, because of those changes in your brain, the headache goes away. Similar thing with antidepressants. People have certain maybe depressive thoughts, and they might take an antidepressant, which literally changes the sort of balances of chemicals in your brain, and the hope, in the ideal scenario, by those changes in the brain taking place, that will cause you to have less depressive thoughts. Or similarly, scientists could go in and they could actually sort of electrically stimulate specific parts of your brain, and when they do, it'll cause you to sort of experience a flash of red in your visual field. So as we get more and more of this evidence of things happening to the brain, causing things to happen to the mind, for instance, there's so much of that evidence that some people have started to believe that the brain and the mind just are one and the same thing. Now, that's a controversial view, but I'm just sort of putting it out there. However, even for those people that think that the mind is something different than the brain, maybe something non-physical, people who believe that we have a non-physical mind or soul still tend to think that the soul is somehow intimately connected to our brain. So they think that there's a kind of like bridge between the brain and the mind. So these are two separate things, but the brain sort of gets information about the environment and sort of sends it across the bridge to the mind. So the mind can then sort of have experiences, sort of think about those experiences and reason, and then make decisions. And then the mind can then send that information it thought about and the decisions it made, send it back over the bridge to the brain. And then the brain can send signals to your body to sort of get it to do what your mind is sort of telling it. So, I mean, all of that's controversial, but notice on all these views, the brain is still intimately tied to how it is that we make decisions. And so if we want to know if our decisions are sort of in control of our actions, we might want to look very closely at how things work in the brain. But that brings up the question, why should you think that studying how the brain produces decisions, how could that give us evidence against the existence of free will? Well, it has to do with, in the mind, it looks like there is sort of conscious thought and there's unconscious thought. So think of this as like the iceberg picture in the background here. Your conscious mind includes all the thoughts, decisions, experiences that you are aware of. So they're above the level of consciousness. But then there's also a lot of things that might happen in your mind or in your brain that you're not aware of. These are sort of unconscious things happening in your brain or mind. And so now the idea here is, well, which decisions or which part of your mind is in control? Is it the conscious stuff that you're aware of, or is it all this unconscious stuff that you're not aware of? So the worry from neuroscience is that we're supposed to worry that our decisions are produced unconsciously by our brains and that we become aware of them only after the fact. Why is that worrisome? Because it seems that deciding freely depends on deciding consciously. So it depends upon these decisions of happening in our conscious brain or mind. But if all our decisions are made unconsciously, it seems that it's not up to you what you decide. It seems like that decision is not within your control if it's happening outside of your awareness. And that certainly looks like bad news for free will. So we'll look at that in a lot more detail in the next video. So let's take a little bit closer look at some ideas from neuroscience and some of the tools of neuroscience. We're not going to go into much detail, but just enough to understand Benjamin Libet's experiment. So neuroscientists aim to study the structure and function of the human brain and the nervous system. Now, one important tool for neuroscience is the EEG machine. So you can see a sort of picture of this in the background on this slide. An EEG machine is a machine that uses small metal discs attached to your scalp. So that's the cap that this person is wearing on their head. And those discs measure sort of changes in electrical activity that occurs in your brain. So it can tell how much electrical activity is being sort of sent back and forth between sort of neurons in your brain. It can't tell which specific area of your brain is lighting up, but it can tell how much activity there is. All right, now here's an example of an EEG reading when someone is sort of doing various things. You can see that the electrical activity is sort of going up and down, and it sort of creates a kind of wave on this printout on the sheet. All right, now, previous research sort of discovered what has been called the readiness potential. So the readiness potential is an increase in the electrical activity of your brain slightly before voluntary bodily movement takes place. So what do I mean by a voluntary? Take a bodily movement. Consider like raising my hand. Well, there's a difference between voluntary and involuntary bodily movement. So for instance, if I just right now raise my hand, that seems to be voluntary. If someone were to grab my hand and raise it for me, or if I were to have a seizure, an epileptic seizure, and my hand were to sort of shoot up, well, that would be me raising my hand involuntarily. So we'll take those voluntary cases where I'm not having an epileptic seizure and nobody's sort of grabbing my hand and raising it for me. That's a voluntary bodily movement. And the readiness potential is an increase in the electrical activity in my brain that happens slightly before I actually perform that movement. So an example here is if you ask me to spontaneously raise my hand, well, you'll see a slight increase in electrical activity in my brain would start to show up on this EEG machine about 550 milliseconds before I actually raise my hand. So you can see this in the background. I have a printout of an actual sort of readiness potential reading. You can see the electrical activity is relatively flat, and then about a half second before the action, you see that little hill start. You see the electrical activity start to climb up, and then it sort of shoots down after the action. Here's maybe a cleaner one just for you to sort of see. So the vertical line here is sort of electrical activity. The red is measuring how much electrical activity there is. And then on the horizontal axis, we're measuring time. So 0 marks the time that I raise my hand. Well, if I go to the left of that, I'm going back in time. If I go back about 550 milliseconds, you see that electrical activity, the red line, you see it start to go up before I actually raise my hand. That's the readiness potential, that little hill that comes before the voluntary bodily movement. All right, so Libet here, his experiment also measured the time of the readiness potential, but that wasn't anything new. So Libet, when he did that, that's not what he was focusing on. His innovation was to develop a new technique that attempts to measure the time when a person first becomes conscious of their decision to move their body in cases of voluntary movement. So the EEG machine is just measuring electrical activity that's happening in the brain. Well, are the things that are happening in the brain during the readiness potential, are they conscious or unconscious? Nothing in the EEG machine tells us whether any of that is conscious or unconscious. It just says there's activity in the brain. How can we measure when a person becomes conscious of a thought or urge to sort of move their body. So a scientist isn't aware of, cannot feel someone else's decisions. So how in the world could you measure or observe when someone sort of consciously makes that decision? So Libet's innovation was to use a special kind of clock. Here's a picture of it. So you can see like the 5, 10, 15, 20. And you see this little green dot moving around the clock pretty quickly. So Libet asked his subjects to spontaneously flex their wrists whenever they choose. So that's the voluntary movement. Now, at the same time that they're doing this, the subject is hooked up to an EEG machine measuring the electrical activity in their brain. So that doesn't tell us whether they're conscious or unconscious of anything. But they're also attached to a machine that's hooked up to their wrist that tells us when they flex their wrist. Then lastly, the subject is asked to watch this dot moving around the clock. And this is important because the subject is then going to be asked to pay attention and mentally note where the clock is when they first feel or become aware of their urge or decision to flex their wrist. So the idea is, even though the scientist is not can't feel the subject's sort of consciousness or awareness, the subject themselves can feel their own thoughts, can feel their own consciousness. So this is that Cartesian idea that we're all aware of our own conscious thoughts. And so the subject is aware when they feel that urge to flex their wrist. And the subject is also aware of this green dot moving around the clock. And so they're supposed to say, well, when they first feel that urge in their consciousness, they're supposed to sort of try to note where that green dot is on the clock when they feel it. And so when the subject finally flexes their wrist in this experiment, the dot stops moving. The subject is then asked to move the dot to the location, using a mouse to the location on the clock where the dot was when they first felt or became aware of their decision. So this is important because the scientist has a record of the time that the dot was at that location. And so Libet's idea is that the subject becomes aware or conscious of their decision at the time the dot was at the relevant location that the subject reports feeling their urge. So Libet was attempting to measure 3 things in this experiment. First, he's trying to measure the time when the subject flexes their wrist. This is measured using the machine that sort of detects muscle movement. The time when the readiness potential occurs. So just trying to measure the electrical activity in the brain and when it starts to rise. This is measured using the EEG machine. And the time when a subject first becomes conscious of their decision to flex their wrists. So this isn't just a measure of the electrical activity. The idea is, when does the subject feel or become aware of their decision? This is the purpose of the Libet clock. It's to say not only when there's electrical activity, but when the subject becomes aware of this feeling or urge. And the idea is, so the subject feels the urge and they see the dot, say, at the sort of 5 mark on the clock. And then, so after the sort of clock stops, they move the dot back to the 5 and they say, that's where I felt the urge. The scientist then goes to the records and say, okay, the green dot was at the 5 at 3:02 p.m., 57.27 seconds. And that tells them when the subject felt the conscious urge to flex their wrist. All right, so what were the results then? When Libet ran this experiment, when did he notice these things happening? Well, the EEG measured the readiness potential starting on average around 550 milliseconds before the subject flexed their wrist. So just like the earlier experiments. Well, what about the conscious decision? Well, on average, subjects reported becoming aware or conscious of their decision or urge to flex their wrist about 200 milliseconds before they flexed their wrist. So this means that the results of Libet's experiment measured the timing of events as follows. They happened in this order. First, the readiness potential begins in the brain, so the electrical activity starts to rise first. Then slightly later, the subject becomes conscious of or aware of a decision or urge to flex their wrist. And then lastly, the subject flexes their wrist. So on this sort of view, it looks like the readiness potential at the beginning, what's going on in the brain there when the readiness potential begins, is happening below the level of consciousness, since the subject is not yet aware of any decision that they're making or any urge to flex their wrist. And it's only later that a decision sort of comes above sort of water, it comes above sort of consciousness. So here's a picture of that sort of idea. Starting on the left, that's an earlier in time. Going to the right, we go to later in time. So first, the EEG measures the increase in electrical activity at about 550 milliseconds before they move their sort of wrist. Then we still slowly go to the right, and then sort of this little thought bubble, that's consciousness. The person has this urge. Maybe they're thinking, I'll flex now. And then slightly after that, their wrist actually flexes. So those are the results that Libet got. In our next video, we'll talk about why this might be a problem for free will. See you then. Bye-bye.